that means we found significance. So, you collect your data, you've set your alpha, you collect your data, you stick your data in the software package, you've made the decision which statistical analysis you're going to run. You ask the software package to run the analysis and it spews out the answers. And the first thing you look for is your P. Right? Because if we go back, right, what we want to happen, our research hypothesis is we want something to have a big impact, right? If I'm testing this training program, what I want is for this training program to make a massive difference in this athlete's performance, right? So if, whether it's a strength performance or flexibility or a skill performance, right? So if I run this thing, I want it to have a really big impact. So I want it to be very significant. So then when I look at the output from the software, that means I need P to be larger than alpha. So if I set alpha at 0.05, I mean less than alpha. If I set alpha at 0.05 and my results come out at 0.07, it's not significant and I can't reject the null hypothesis. I have to say I was wrong. If it comes out at 0.04 or lower, then I can reject the null hypothesis and I can say, I was right. What I thought might happen, happened. That's really cool. Right? That's great. So we like it when we find significance. It doesn't mean, however, that if you don't find significance, you didn't find anything. Right? Because if someone is trying to sell a workout program and you buy in and you go, oh, this is a cool workout program. I'm going to run an experiment. And then what you find out is the results are not significant. That's a good thing to find out, because why are you going to pay someone for something that doesn't make any difference? Right? So not finding significance isn't technically a bad thing, it's just a bit, you've spent a year collecting this data and running this research and planning it all and getting all excited, and you press the button and you go, it's like, right? Right? It hurts your heart when you don't find significance. But that doesn't make it a bad piece of research. Right? It means you didn't find what you hoped to find, but that still could be very important. Okay? Let me see what I have there. No, let me go back here. Okay. What do we set alpha at? Mostly in PE kinesiology papers, we set alpha at 0.05. So most of the papers that you read will have alpha at 0.05. Not all of them, but the majority of them. That's a pretty safe alpha for our kind of research. Because what alpha says is the probability of finding the null hypothesis is true. Right? So, when I set alpha at 0.05, what I'm really saying is that I am 95% certain that the difference I found is due to what I did. Okay? Now, mostly, what we do is not life or death, right? Coaches may think it's life or death occasionally, but it isn't life or death, right? We're playing a game. If what my research is a new drug. And what I need to know, I'm going to put out on the market a new drug to help heart disease. Right? But drugs, there's always a risk with drugs, right? Every time you see an advert for a drug, it says, the risks are blah, 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 blah. And you're like, why the hell would I take that drug in the first place? Okay? Well, what if the risk is you're going to take this drug to help your heart disease, but there might be a risk that it actually kills you? Right? So I'm going to run research to find out whether it helps or kills you. Am I going to set alpha at 0.05? Am I going to say, I'm 95% sure this drug won't kill you? Is that acceptable? What do you think, Charlie? Is 95% okay? If I'm going to kill you, you willing to take a 5% risk on whether I'm going to kill you? No. Right? So, if, depending on what the study is, 0.05 may be way too big. So in chemistry or in medical literature, they often set alpha at 0.01, because now I'm saying I'm 99% sure I'm not going to kill you. Okay. Sometimes, hopefully not in PE or kinesiology literature, although I have seen it occasionally, and I generally just throw the article away, right? Occasionally, people will set alpha at 0.1, particularly in sociology type questions. So I want to know if wearing blue affects whether you laugh during the day, right?
So just like a yes or no question,
Yeah, or something where, you know, if I'm 90% right, that's okay, right? In PE and kinesiology literature, we shouldn't be setting 0.1. 90% isn't good enough. 95% is typically acceptable. Occasionally, they'll set it a priori at 0.01, but usually the a priori measure for us is 0.05. Now, if they get 0.01 on their software output, they're going to tell you they got 0.01, because that's really, really good, right? If they say 0.1, I would really question whether I wanted to read that paper, because that means it was a pretty weak setup for us, because we're not in sociology. And, okay? Does this make sense? All right? So again, you don't have to learn it. It's not something to be panicking about, oh, I've got to know, because it's just when you're reading, this is what you want to start looking for. Because if you pull a paper and they say, we set alpha a priori at 0.1, you need to look at the paper and work out whether you want to bother reading it in our field. Because it's likely to be quite weak, and so it might not help you very much. So, we've set our hypothesis. We have a research hypothesis, a null hypothesis. We've got alpha. We know that P is 0.05, and what I'm hoping to get is an answer on my analysis that comes out at less than 0.05. And one of the reasons we set the alpha a priori, and we're looking for P, is something that you often see called type 1 and type 2 errors. And a lot of papers don't ever mention type 1 or type 2 errors. If you read theses and dissertations, they will tell you that, because every single thesis and dissertation committee wants to know that you know this. Right? A type 1 error is pretty bad, because a type 1 error means that I rejected the null hypothesis when it was true. Okay? So the null hypothesis means nothing happened. If I reject it, that means something did happen when actually nothing happened. Right? So if I go back to my drug idea, and I set it at 0.01, and I reject the null hypothesis, I say I'm right when actually I'm wrong, that would be very, very bad, right? Because I kill people. So type 1 errors are pretty bad. We don't want to say I'm right when I'm wrong. Okay? Obviously, but that's what that's saying. And I say it like that because when we look at a type 2, we're looking at a different type of error. Because what we do in a type 2 is we say I was wrong when actually I was right. Okay? So, I make an error, but it's a better kind of error. Because I'm not going to kill someone this way, and I could kill someone this way, right? So if I say I'm right when actually I'm wrong, that's a worse error than saying I'm wrong when actually I'm right. Okay? So type 2 is a preferable error. If I'm going to make an error, it's better to make a type 2 than a type 1. And so part of the verbiage that you see around alpha sometimes is that we set alpha at 0.01 to reduce the risk of making a type 1 error, right? You don't need to get, as you get used to the terminology, it starts to make a bit more sense, right? But you're going to see it, so I want to explain it a little bit, so that you're not reading it going, what the hell is all this mean? When they talk about power for the study, the power for the study is how much chance have I got of not making the type 2 even, right? The more power the study has, the less chance I've got of making a type 2 error. So, if I only use 2 people for my study, then I could make that type 2 error. If I use 200 people for my study, there's less chance of me making a type 2 error. Now, power isn't always more people. It usually is more people in our case, but it isn't always. And power depends upon what it is you're testing, what kind of statistical analysis you're going to run. You can't decide power. I can't decide power, right? I set it up and I hope it has power. You can, I can't. We would have to ask the statisticians in the math department to run a power analysis for us ahead of time, right? So they can say, okay, what's the design? What are you looking at? What's the question? What analysis are you going to run? This is how many people you would need to collect data from in order to get power, right? You can do that ahead of time. When I ran my dissertation, I didn't run a power analysis because I only had 24 children in the daycare. It didn't matter whether I needed 50 children. I only had 24 children. So the power analysis was irrelevant because that was all I could get hold of. And it either was or was not enough power, and I was going to have to deal with the outcome of the statistics in either case, right? So you don't always run a power analysis, but quite often you can ahead of time, especially if it's going to be an expensive study. You don't want to run a study on 19 people and find out you needed 21 people to get power. Because that's a whole waste of money for nothing at the end of the day. Okay. When you're reading, they're always going to tell you whether or not they found significance, right? Did they find significance? Less often, unfortunately, they will tell you what their effect size was. And technically what that means is I can have mathematical significance without having a practical situation that's useful, right? So I could get P, my P could come out at 0.48. 0.048, right? If I set alpha at 0.05, then I made significance. I can report that I found significance because I did, right? That's not cheating. But if P is 0.048 and my effect size is 0.13, it means that this is no practical use to me whatsoever. So it's interesting how rare finding information on the effect size of something is in articles, because this is really the key, right? In our world, because we are hands-on practitioners, right? We're going to be teachers, we're going to be coaches, we're going to be physical therapists, then the practical situation of the result is of huge importance to us, right? It may be statistically significant, but if it's practically ineffective, then that's not very helpful. What we want is something that meets significance and has a medium to large effect size. What happens in the literature quite often is that the editor does not require an effect size, and so they don't report it. Because maybe it wasn't very good. Trust me, if the effect size is great, it'll get reported. Right? So often when you read papers and they don't report the effect size, that can be because it was a little bit dodgy. But again, it depends on the paper and the stuff that you... If it's not very applied, if it's a theoretical question, then the effect size is less important. The more power the study has, the better chance they're going to have of picking out the effect size. So everything ties in together. The effect size, sometimes they'll literally say effect size. You could see something called Cohen's D or Cohen's F. That would be a measure of effect size. Eta squared, which is similar to R squared, although R squared isn't always thought of as an effect size, but eta squared is an effect size, so if they report eta squared, that's a good thing to look for. Right. It could be in the table. If they put their results into a table, it might be one of the columns in the table. They may actually verbalize it in the text. But it's a good thing. If you find an article that reports the effect size, that's that's a good article to hang on to, because the authors often avoid reporting that if they can. Because it gives away the fact that the study wasn't quite as great as they're trying to make it out to be. So, this stuff is mostly terminology. Although I have to say, nowadays, you guys are going to have a lot more option to read qualitative papers than I had. Because there just was not that much qualitative research done within PE and kinesiology. It's becoming more popular. But most of the papers you read are likely to be quantitative. So this information is purely verbiage. It's just language that if you have some idea what the language means, it will make reading the paper a lot easier and more meaningful. You'll be able to actually get what the results are trying to say. That's all. You don't have to learn it. No one's going to accept. Well, we almost certainly will ask you why did you set alpha at such and such, or what does alpha represent? But that's a major global, I mean, that's a big concept. We're not going to ask you about eta squared in an exam. Right? You don't have to learn it. You just have to be able, you have to go, oh, didn't she say something about that term? I don't remember what it is, look it up. Okay? Ooh. All right. Any questions? Anything that I made even more confusing than it was to begin with? No? All right, so I will get purpose statements and references back to you with your grade on that, so you can see where you stood with that. And then I will hopefully early next week, if I can do it by the end of the week, if they get it back to me quickly enough, I'll get it back to you as quick as I can. But I'm assuming if I send it to them this afternoon, that they won't get it back to me until Monday. But I'll get you the feedback from the other faculty as well, so that you've got more than just my point of view on your purpose statements. Okay. Any questions on ANOBIT stuff? Because that's the next thing that's coming in next week. Any questions on that yet? Or are you still in spring break mode and haven't looked at ANOBIBs yet? All right, don't leave that too long. All right, because you do not want to be scrabbling for ANOBIBs at the last minute next week. Okay? All right, thank you. Don't forget your phone. Don't forget my phone.